Assalamu alaikum. This is Dr. Ghulam Muhyiddin, and our today's lecture is about a step-by-step hands-on estimation of simple linear regression model using Stata 15. So first of all, I would like to thank you for watching my videos, and I would request if you like this video, please like and subscribe my channel so that you may continue getting updates on my latest videos and the lectures. So today we are going to start a series of the lectures on the empirical estimation of econometric modeling using Stata. So our first lecture is about the step-by-step guide to estimate the simple linear regression model using Stata. This is a simple and easy to understand and a step-by-step hands-on tutorial on the estimation of simple linear regression model. We are using Stata for the estimation. There are a number of the more software which are available where that can be used to estimate different econometric models. But Stata is the simplest tool which is being used for the econometric estimation of the model across the world by the universities and the students. So we will deliver this lecture through the use of Stata. So it will be first of all, before going into the details of the simple linear regression model, it must be noted what is the simple linear regression model. As everybody knows, that simple linear regression model is the simplest form of regression model where only one independent variable. There is a one dependent variable and only one independent variable. And how we write this, how we can depict this model, we will look at the equation, and let me show you how can we elaborate this model using some econometric or the statistical equation. A typical equation of simple linear regression model. A simple regression model is a linear model with the only one independent variable. It can be represented by the following equation, where the y is equal to alpha plus beta x plus epsilon, where y is the dependent variable, x is the independent variable. Beta and alpha are the unknown parameter that we will estimate using Stata, and epsilon are also the unknown parameter which is called the error term. So our basic objective is that we are not going into the details of the theory behind the simple linear regression model. We are not going to discuss about the classical linear regression modeling, or what are the Bayesian theory, what are the classical linear model, and how these betas are derived statistically or the mathematically. Here our objective is to estimate the econometric model using is the practical application of the simple linear regression model to estimate the betas, alpha, beta, and epsilon. So we will not go into the detail of the theory. We just focus on the estimation of the model or the hands-on and the practical tutorial about estimation of statistical or the econometric model of the simple linear regression using Stata. We will use some sample data from the Principle of Econometrics Volume 4. I have given the detail or the reference of the website from where you can get this data. I have given the link of my website from where you can download the links of the data. You can read about how can we estimate these model, and if you need, anybody needs a do file for 2 days project or the 2 days practical experience, please in comment box write your email and request. I will email you all the relevant data in the do file. And now we are moving towards the practical application or the estimation of the model using Stata. So this is the Stata. When you will open Stata in your computer or the laptop, you will see this screen. So first step in estimation of any model or solving any equation, model or assignment in the Stata or the data analysis in the Stata, the first step is to import the data or open the data in the data set into this Stata. So how can you open this data? There are a number of the way. If you have a file downloaded in your computer, you can go and click file open and search any data you have in your at your desktop, at your download folder, wherever you have placed the data set. For instance, the data what we are going to use to solve the simple linear equation or the simple linear model, we are using food expenditure data. Here it is shown that I have downloaded in the downloads folder. The other way, you can download it from use and write the address of the website from where you can download. For instance, you can download the dataset from this website. Use http colon forward slash forward slash www.principlesofeconometrics.com forward slash POE4 slash data slash stata slash food dot DTA. Dot DTA is the file extension of Stata format of the datasets. Any dataset which can be opened in the Stata has the file extension of .dta. So here is the website. I have written these all details, all steps on my website, of which I am giving the link in the description of this video. You may download, you may click this link and you get the download link from where you can get the data which we are going to use for this example. You may replicate using this data. For replicating, you have all of the codes used in this lecture on my website. So here we entered use and the web address of data file, and here on the right corner there are two variables which are being shown, that the food expenditure. Here is the detail of the complete name of the variable. Here is the short name which is the food underscore exp, means the food expenditure. Here is the label of the variable. This means it is household food expenditure data for per week. How many a household spent on the food within a week. And the next variable is the income, and it is the household weekly income data. So first step before estimating the model, we need to review the data, and for reviewing what type of data, what type of the variable are available in this data set, we use the command describe. On command window, we will write describe and then just enter. Here it shows that the file food.dta contains a data from this web link. It has 40 observations and only two variables. And as you all know that we are going to estimate a simple linear regression model where we need only two variables, one dependent and one independent variable. 40 observation and two variables, and the further description of these two are shown as: this is the storage type, this is the display format, these are the statistical format for the data, whether it is a double or the integer. So we are not going to going into the details of the number and the types of the variable or the storage type. We will discuss in the introductory lecture on Stata, but here our today's lecture is about the estimation of linear regression model. So we are not going into the details of these things. So the food expenditure and the complete label of the variable is the household food expenditure per week and the weekly household income. And now this is also being shown that the data is not sorted. If it is sorted by one variable against the food or the income, it should have been shown here. And the next step, the second step in estimation of the linear regression model is to see the summary statistics of data. And for getting the summary statistics, we use the command. We will write summarize in the command window, and we will get the summary of these two variables. The summary command, we can write the short form only sum, give the same results. Sum is the short form of summarize command. So this gives the overall the brief summary of the variables that we have 40 observations for both variables food expenditures and income. Mean of the food expenditure is 283.57, whereas the mean of the income is 19.604. Standard deviation of the food expenditure is 112.67, whereas very less standard deviation for the income 6.84, whereas the minimum value of the food expenditure is 109.7, whereas the minimum value of income is 3.69. Similarly, the maximum value for the food expenditures are 587.66 and maximum value for income is 333.4. You can get the detailed summary statistics. For instance, instead writing just summarize or the sum, I write summarize, comma, and detail. So here we get the detailed statistics, we get the percentile data, we get the smallest value, largest value, percentiles of income, percentiles of food expenditures per week, percentiles of the weekly household expenditure. Here we have only two variables, but if there is a large data set and we are interested in detailed summary statistics of only one variable, then how we would use, we will write summarize. For instance, here we want to review only one variable food expenditure. So we'll write the name of the variable in which we are interested, comma, and detail. And you will get the results of the concerned variable in which you are interested. And the next step, before estimating the model, we need to verify through the observation that what type of relation the data shows, what the data shows. And mostly in econometrics or the statistics, we use plotting the data, plotting the two variable. And in the if we have only two variable, the most suitable visualization technique would be the scatter plot or the scatter diagram. So here we will plot the scatter diagram of the two variable. So the command is the two-way. In parentheses we will write the type of the diagram, which is the scatter diagram. For this we use scatter space first variable food expenditure space second variable income, and close the parenthesis and just enter. And here we get this type of the scatter plot or the scatter diagram. On the x-axis we have taken the weekly household income, and on y-axis we have taken the household food expenditure per week. So this is apparent that as the weekly household income goes to the rightwards or increases, the household food expenditure likely to increase with the increase in income. So to estimate the model, we use the regress command. We will write regress space dependent variable. Here we assume that the food expenditures are dependent on the income. It means your weekly food expenditures depends on your weekly income. So we just write regress dependent variable space independent variable and just enter. And here we get the results as under. Those are being shown on the screen. In first part of the result window, there is sum of the squares of explained variations for how much is explained by the model and what is remained are the residual or which is unexplained. Here is the number of degree of freedom for the model and 38 for the residuals. Here is the mean sum of square. We mostly interested in ANOVA results, which shows the F test. The value of F test is 23.79 and which is significant at 0.00. So our F test is significant, and the second most important statistic in which we are interested is the R square and the adjusted R square. So the overall significance of model is clear. It is significant at 0%, less than 1% margin of error. Adjusted R square is 0.37 roughly, where the root mean square error is 89.517. So these all are the important parameters which are reported in the regression model. And the second most important part are the coefficients, which shows the relationship existing between the income and expenditure. Here, the coefficient for income is 10.2 with the standard error of 2.09, where the t value is 4.88, which is highly significant as it is shown by the probability 0.00, and here is the confidence interval of the coefficient, which ranges from 5.97 to 14.4. So these are the results of our first simple linear regression model, which is the most basic model in the econometrics to start with. So this is all about the estimation of simple linear regression model. If you have any query, you can post it in the comments and you may ask. I will write the link and in the description box from where you may access my web page. Here it is shown, which is www.mohiyuddin.com, and here is the link of this first lecture on the simple linear regression model. Here you will get all the links of data sets, all the commands, roughly a do file. If anybody needs just a do file of all these estimation, I can share. If you write in request for sharing in the comment, to like this video and subscribe this channel so that you can get updates on the latest lecture. In part 2 of the simple linear regression model, We will discuss about the post-estimation test of the regression, what type of test are run after the estimation of regression model we will discuss, and afterwards we will continue this econometrics course and we will go to the multiple linear regression model and other estimations and testing. So please subscribe my channel so that you may get the updates on the new lectures and the videos. Thank you very much for watching. Goodbye.